All right, Calgary, how's everyone doing? Wow, what a crowd. First of all, thank you all so, well, first of all, I have to say, what do you think of my space pants? It's mixed response. I have to thank you all so much for coming out and supporting this event. This is our first big event in Calgary, and I've just been blown away by the level of support here. So please give yourself a big round of applause for coming out today. And those of you who don't know, my name's Travis Pangburn, and I'm the creator of Pangburn Philosophy. And we travel around the world and promote art and science. That's what we do, and we do this in many different ways, and some of the ways that we do this is through large-scale live discussions like this. Carolyn Porco's in the house tonight, and this is our first event with Carolyn Porco, which I'm so excited for. So just a couple things. We will, after about an hour and 15 minutes, have a Q&A. There's a Q&A mic on each side of the audience down here that will let you know when you can come down and stand in line if you have a question for Richard or Carolyn tonight. And then there will also be a book signing in the lobby for those of you who have a book authored by Richard Dawkins. So feel free to take part in that if you do. What else? I think that's it. That's all I have. It's becoming popular to think. We're able to fill venues like this all around the world, and I think that means that we're heading towards a great era in humanity. So thank you all for being a part of that. All right, I can't wait any longer. I'm going to ask you to put your hands together again for Richard Dawkins and Carolyn Porco.
Thank you. Hello, Calgary. So, okay, well, I thought we would start with a little story of how Richard and I met, because this is not the first time we've
You'll hear Carolyn's version first, and then we'll see.
So, I think it was 1998 or 1999, which puts it at about 20 years ago now. We both were invited to Warner Brothers Studios in LA to participate in a panel discussion about the way that Hollywood was portraying scientists and science. And there was quite the panel. There was Richard and I, who did not know each other at that point, James Watson, okay, DNA man, a couple of people from Hollywood who were big names. One guy was the executive producer of NYPD Blue, which at that time was a very successful show about policemen, and he'd really got it all right. You know, it was very gritty, showed really the true side of what being a cop was like. So he was the wunderkind of the moment. He was really lauded in Hollywood. And then there was a guy who was the executive producer of ER. There was a guy who wrote the book, is it Big Man, Little Boy, about the atomic bomb? And others were there, and then there was Richard and I. And so we had this just discussion, and one of these people, I'm not going to say which one it was, went into this tirade about how scientists were basically evil. And he never met a scientist that he could look in the eye without, wincing, or the scientists without wincing. Just painting scientists as if they were these dweeb people. He said, everybody knows the scientists never got the beautiful girls in high school, and on and on and on. And I was getting hot under the collar about all this. And I eventually, I don't know if I can use this word in Canada, I eventually called him an asshole.
What happened was that, first Jim Watson said, "Are you for real? You sound like an escapee from the Yale English department." and then Carolyn, I think, said something.
Whispered
something, and then he yelled out, Oh, so now she's calling me an asshole.
Yeah, so you can imagine it went downhill from there. But it was really this battle between the Hollywood people who thought they did not owe science anything. They were not honor-bound to present science the way it really was, and they could do anything they wanted. And Richard and I were on the same side of the argument, saying, well, but science is the most valuable thing we have, and it really should be portrayed accurately, and even just stories about the pursuit of the truth would carry, as stories that would be, you'd get an audience to watch and so on. So Richard and I kind of bonded at that point and became, pals because we were on the same side of the argument.
Yeah.
So anyway, that's how we come to be here. So I thought that we would start. I have a whole list of topics. It goes on for 4 pages of what we might talk about. I don't think we'll get through it all, but we're going to start with basically what Richard and I have in common, and that is that we're both scientists, but we're interested in life. That is, what is life, the process of life, and how did it originate, and how do we go in search of it? And so it's important to first talk about what it even is, and that's important when you want to go search for it to know what you're looking for, and it's amazingly difficult to find a definition for it. There's no one group of people who could come up with a definition that satisfies all those organisms that you would call alive. Some would have the attributes that or meet the definition that you might put together, and others wouldn't. You agree with that, right?
Yes, I mean, I think it is a remarkable fact that without ever violating the laws of physics, at least on this planet, there have grown up objects, entities, which are exceedingly complicated, staggeringly complicated compared with anything that physics alone can do, and which have the very, very strong illusion of being designed for a purpose. It's no wonder that most people in the history of the world have been creationists, believed that they were created by a divine creator, because we look designed. All living creatures look designed. We have every attribute you'd expect if somebody had designed us. By us, I mean trees and kangaroos and lions and us and fleas and bacteria. Working with great complexity and detail to further an end, which is survival and reproduction. So I suppose one way to put the question is, if we found life on another planet, how would we know it was there? How would we recognize it? And I think it would be complex, and it would be purposeful, designed for a purpose. Many people don't understand it. My tie, for example, you probably can't see it, but these are leaf insects, and they look uncannily like leaves. You couldn't possibly think that happened by accident. It didn't happen by accident. It happened by natural selection.
But not by a designer.
But not by a designer.
Yes.
And it was Darwin's great triumph to realize that design, this prodigious illusion of design, can come about without a designer.
Right, so this whole thing about how you get to that stage is going to be the next topic. But let's first just talk about this. What are attributes of life, right? It has certain architecture. Life is built modular, like Legos. You can start small and build something big from common elements, like common chemical elements. All life on Earth is built of certain common chemical elements. Cellular. All life on Earth is cellular, right? Would you say?
It is, but does it have to be? And I think it's an interesting question whether life always has to be cellular.
Okay, but when we go and search for things anywhere, either on Earth or on other planets, which is my business, you have to know what to look for, right? And
it's not obvious that when you're going looking for life that it should be made up of lots of little units. Maybe it has to be, but that's a case that has to be made. I think it's a very interesting question to ask. What are the attributes of life that just have to be true because there's no other way to do it? And cellularity might be one of them.
Replication, right?
Replication, I would bet, is one of them. Sex probably isn't, because we have creatures that are not sexual. But I would like to know how much of what we know about life on this planet had to be true because that's the only way it could be, and how much just happens to be true of our form of life. And our form of life is uniform, it's all based on DNA. The fundamental machine code of every living creature we've ever looked at has been the same, and it's sort of the superficial details that are different. And I would like to know, is it necessary for life to have a genetic code? Does it have to be digital, as ours is? Does it have to be a one-dimensional digital code, as ours is? Or could you imagine a two-dimensional matrix? Does it have to be very highly accurate, as ours is? I think it probably does. These are all questions which you can ask about lives, in the plural, in general, even before we've even been to look for others. I would put my shirt on, all life having to evolve by natural selection, some form of natural selection. And that implies there have to be something like genes. But does it have to be DNA? Does it even have to be based on carbon chemistry? I think it does. Would you think so?
Well, I don't really have an opinion about that because I don't know enough about the chemistry to say. But I'm saying that you've just laid out on the table a lot of questions that, you know, if we're going into the solar system or we're looking at exoplanets and we want to know what in our business we call biosignatures, what we look for, some of those are just almost impossible for us to grapple with. That's why you hear, you know, the mantra at NASA is follow the water. I mean, we are starting in kindergarten. We're going after the kind of life that we know how to recognize. And so it's looking for those attributes or those chemical processes that we think could be attributed only to life. But you bring up, I mean, obviously that's the more interesting thing to think about is how different could life be elsewhere? Could you have life? Okay, so just let's take two examples that I think about. Having just completed the Cassini mission, I led the imaging team on the Cassini mission, and we found, the Cassini project found that the small moon Enceladus, no bigger than England, small icy moon, actually, when we got there, we found a plume of material erupting from its southern pole. And over 13 years, we found that that plume is really 100 geysers erupting from fractures in the ice shell underneath which is a global ocean that is as salty as the Earth's, is laced with organic compounds, bears evidence of hydrothermal activity like that found on the Earth's seafloor. And so this was wildly exciting, and that is an example of the kind of environment that we would expect life to certainly survive in. Whether it could originate in such an environment is another question, because we don't know how life originated. But certainly it's a watery environment, so it's, you know, it's really got us very interested.
How many people here have seen Carolyn's magnificent pictures of the Cassini mission to the Saturn system? Carolyn, would you mind if I described you as the female Carl Sagan? Would that be?
I'm not going to. I'll take it. I've been called worse.
I love the way you feel, although you haven't been to the Saturn system. Cassini has, and you talk about when we went and we turned around and we orbited this and we did that. You must have felt you were actually there.
Always.
Is that right?
Always. I feel like I lived my life in the outer solar system.
And how long
so much so that I had a hard time keeping up with what goes on down here.
Yes, just as well, I think.
Just as well.
So how long were you exploring the Saturn system?
Well, okay, we were there for 13 years. But frankly, the mission got started in November of 1990. So basically 3 decades of like being committed to this.
And how long did it take to get there?
It took 7 years of travel, but it took us 7 years to design and build the spacecraft and the instruments and launch it.
7 years to design and build, 7 years to get there, and then once you were there, how long were you actually exploring?
13 years.
And you could take a decision. I think we might go and look at so-and-so now. Let's go and visit Enceladus, shall we, now?
Well, we planned the whole trajectory years in advance.
Okay.
I mean, like our nominal mission was 4 years, and we did that. We started planning that soon after launch. I mean, that's quite a job because we planned like I forget, so don't quote me on this, but every 5-minute interval in 4 years had to be planned. What are we going to be doing? Which instrument's going to be prime? What data are we going to collect? How are we going to turn the spacecraft?
But could you decide at some point, let's go back and have a look at so-and-so?
Okay, so the reason why we could do that, I mean, to a singular degree with Cassini was because we were in orbit. It wasn't like the Voyager mission, which I was also on in the 1980s, where we flew through the giant planet systems of Jupiter, Saturn, Uranus, and Neptune. We spent about a week in close proximity, gathering as much information as we could in a hurry, and then that was it. It was off to the next one. You know, years. It took us years in between. With Cassini, we were in orbit around Saturn, so we had the leisure of finding something like the plume on Enceladus and deciding, okay, this is so exciting, we got to really come back and take another look. And thankfully, we were given mission extensions. The mission was supposed to be only 4 years long, and then we kept getting extended, obviously, for another, whatever that was, 9 years. And it was in the extended mission that we really honed in on Enceladus and had lots and lots of flybys of it, even flew through its plume, grabbed up material to sample, and so on.
What was it like when you first saw these plumes? It must have been an incredibly exciting experience.
It was at first puzzling. We had to be absolutely sure were we seeing it or not, because our first pictures weren't like the best. But when we finally got up close, we knew we need to go get closer and take a closer look. We took a picture where you see just dozens of these narrow, discrete jets erupting from the surface.
How high do they go?
Oh, well, as discrete jets, they probably go about, I don't know, 50, 100 to 200 kilometers, but they feed a plume. No, that's, no. They feed a plume that goes tens of thousands of kilometers and ends up supplying particles that make Saturn's E-ring. So this big diffuse ring of material that Enceladus sits in is created by the spray that's coming off the surface. So where was I going with this?
Well,
you wanted to know.
I'm sorry.
You wanted to know what it felt like.
Yeah.
I'm just saying maybe this sounds like I don't know, an exaggeration. I just felt like, wow, what must it have felt like to find the geysers of Yellowstone? Imagine the first person, whoever that was, who saw those.
It's much bigger than that.
Well, it's bigger. It's bigger, but I don't know. It's just this, this geological phenomenon no one had ever found before. That's the thrill of being involved in space exploration. You can actually do things like that.
And you think this was salt water coming from an underground ocean?
Well, we weren't sure at first. Well, we, the imaging team, I'm very proud of this, was the first to say, we think this is coming from liquid water. But eventually, over those 13 years, we pinned it down to the fact that there was a water reservoir under an ice shell, and that reservoir eventually we realized was a global ocean. And we also realized, because Cassini flew through the plume and scooped up material and measured its composition, that's when we found that it was salty, and there's organic materials. In fact, there are organics. We now know there are organics that are bigger than, than the average biologically useful amino acid.
Well, I was going to say, because Origin of Life research received a great boost in the early 1950s when the Miller-Urey experiment, replicating what was thought to be the chemistry of the early Earth with flasks and lightning strikes, little electric sparks and things. And they and the world was extremely excited when their flask ocean became filled with organics. And in a way, that experiment, although it caused a big stir at the time, is now completely redundant, because organic materials of that sort
Are everywhere.
are everywhere, including on Enceladus and in meteorites
In meteorites.
as well. So we know that the universe, or at least the solar system, presumably the universe, is filled with organic substances of the very kind that the Miller-Urey experimenters were so excited
I know,
to
but
have found.
Miller-Urey didn't find, I just read somewhere, I think it might have even been in your book. So it must be right. They have found in some, no, maybe it was in some experiment, they were able to make RNA.
Not in the original experiment, but
No, not that, no, but later on.
But presumably there's not RNA on Enceladus. That'd
No,
be
no, but I'm
wonderful.
saying
Yes.
it's that easy to make. They were able to make it in the lab.
Yes.
Yeah.
So on Enceladus, then, there are. Did you say there are amino acids? Or,
No,
sorry.
I just said
No.
that we don't know, we didn't have the equipment on Cassini to identify particular molecules.
No.
Because we're very limited in the masses that we could actually identify. But we were able to determine that there were compounds that were larger than the average amino acid.
Well, what it takes for life to begin is something rather special. It's not good enough just to get some organic compounds like that. You've got to get one that's self-replicating. You've got to get a molecule which makes copies of itself, and not just that, but they've got to be heterogeneous copies. They've got to be more than one kind, which breed true, so to speak. Because only then can you get the competition that's required for natural selection.
Wait. You say natural selection even in determining what ends up being the genetic molecule?
Well, by definition, the first replicator you could call a genetic molecule.
Right.
But I don't think anybody thinks that DNA was the original one that started off here.
Right.
Because DNA it's been called a high-tech replicator. It requires a complicated infrastructure of pre-existing biochemistry to get going. So the original replicator that started natural selection off almost certainly was not DNA, but was something simpler than that, and probably nothing like such a high-fidelity replicator as DNA. And DNA
They call that RNA. RNA is the one.
Could have been RNA, would have been a better candidate. And that's the kind of vogue idea at the moment, the so-called RNA world.
Okay. Well, so...
But you want to go back to Enceladus because you think that's the best hope for finding life in the solar system?
Well, okay, only because, again, in our business, it's, we want to you put a multi-billion-dollar mission together, you want to, convince people you're going to return results. So, we want to know what we're doing. And so we know there's water there. This is very promising in what we found. We know more about the ocean on Enceladus than we know about any other extraterrestrial ocean in the solar system. And so it means that we are in the best position possible to design experiments to go and test if there are things that, evidence of life, okay? Yeah. And so that's why some of us think that it's the best place to go. I'm not saying, I don't think we can say whether or not it's got a better chance of having life in its ocean than, let's say, Europa, but we just know more about it. It's an easy environment to work in, and so we want to go back. Doesn't mean we'll find anything, and this is interesting. It brings up this thing that you have made a point of in your books, that you think, let me back up. People are excited about Enceladus not only because of its ocean, not only because of the organic material we find in the spray that comes from it, but because of this evidence of hydrothermal activity. Okay, and that's like the hydrothermal activity, that's what we have on the brain, is that we see on the seafloor of Earth. And we know there's lots and lots of organisms that live there, and they live there because there's hot fluids laden with minerals that come out of the seafloor, and there are animals that have evolved probably the first organisms that evolved didn't use oxygen because there was no oxygen. They just live off minerals. And so, and the energy and the energy gradients that are there. So we think, okay, well, this is very promising. Let's go see if there's any evidence of such life there. But there is this suspicion that life cannot actually get started in liquid water. And this is an interesting thing to talk about. There are two camps. There's two camps. One says you first have to start, and you first have to build the big biomolecules. You are in that camp. You say the first life will be a replicator. It will be a genetic molecule that can reproduce itself, right?
Yeah, that's got to be true because only then can natural selection get going.
Okay, but then there's the other side that says, the other camp that says, well, we really should be going where there's lots of energy and energy gradients because life couldn't exist without that.
They're not alternatives, but...
well, they're not really alternatives, but when it comes to what should we be looking for,
yes,
that's where...
Well, I found it convincing that, I mean, it'd be very nice to find geothermal activity on Enceladus or Europa because they're a very long way from the sun.
And you need an energy source.
And you need an energy source. And so, whereas we've got plenty of sunlight here,
on the surface.
It's a pretty good idea, I mean, quite a fashionable theory now, that life, even on this planet, arose from the energy source of volcanic energy rather than, in these what do they call them, black smokers.
Okay, so you call that volcanic. I wouldn't call that volcanic, but that's volcanic.
Well, it's heat from inside.
Okay, geophysical heat.
And so the reason why you might not expect to find life originating in the outer solar system is it's so far from the sun. But you've got a very good reason why it should have originated there.
If you can form the genetic molecules in liquid water, and I've spoken to organic chemists who say it's very, very difficult to do. And DNA and RNA live in water now because I guess they're supported by us, because they're supported by other chemicals which make it possible for them to do what they do. But to talk about the first one, absent all the machinery around it, it's difficult to form such a molecule. By the way, you bring up an important point about does it have to be DNA? And could it even have a different structure instead of being a long linear chain? But there are people who, one group in particular that I'm thinking of, that is trying to do this in the lab. There is another way to talk about the origin of life, and that is not only to do it theoretically and think about it, not only to go search for it elsewhere and maybe find it and then make a comparison, but actually to try to make synthetic life in the lab. And one group I know is trying to make a synthetic genetic polymer. And just to throw in a little history, the father of quantum mechanics, Erwin Schrödinger, wrote a book in 1944 called What is Life, I think is the name of the book. And I found this very surprising. I only learned this in the last couple of years. And he actually discussed, this is before, what was the DNA structure, 1953?
53.
Yeah. This was some 12 years before they actually determined what the structure of DNA was. Schrödinger said it had to be like a crystal. It had to be this repeatable structure that maintained itself after every replication. And so, and James Watson and Crick, what's his first name?
Francis
Crick. They said they were inspired by Schrödinger. They had his ideas on the brain when they went to try to determine the structure of it. Anyway, I digress. So there is a group here on Earth that is trying to make a synthetic polymer, and the idea is that not only, and they've elaborated on Schrödinger's idea, saying not only does it have to have a crystalline structure in the sense of repeatable molecules, but it has to be a structure that maintains its shape and also has the same physical and chemical behavior with every repetition. It can't like fold like a protein or else it won't.
That's right.
Right? And so he, the guy who's the head of this group, his name is Steve Benner, he says it has to have it has to be like DNA in that the phosphate group in DNA is, each one is electrically charged. And that means that these phosphate groups kind of repel each other and they keep the molecule rigid. They keep it from folding. Okay, so he's elaborated on this idea of Schrodinger from 1944. He's added some other criteria, and they're trying to build other molecules like that in the lab to see if they work. So that's another avenue of research that is, that's happening in this. But I do want to get to complexity. Complexity is something that just fascinates me. Do you mind?
Okay.
Okay, so you alluded to this at the beginning. You said that it looks to someone at first blush that there's design. Like, how could you get something so ornate, so regular, so even bilaterally symmetric, like those leaf insects?
Well, more than just that. They look like leaves. I mean, bilaterally symmetrical is easy to get. Lots of crystals do that. But to look like a leaf has got to be done something very special, which is natural selection.
Which is natural selection, which is something that leads, it's the whole thing is just amazing to me, that complexity even turns up in the physical world, and it's basically order coming out of chaos. And Schrodinger mentions this in his book. He talks about this process of diffusion, how you could just take a gas and it just eventually just diffuses away. But if you had a gas that was dense enough, it can be modeled as an ordered process. And this random motion actually it's not random anymore. It actually will move in a way that you could describe with an equation. I mean, it's remarkable that you could get order out of that. The same thing happens with gases that emit radiation. If they're dilute, the radiation will be, just singular photons of a singular wavelength. You make the gas molecules very, very numerous. You make the gas dense, and then the thing will shine. We call it black body radiation. The radiation that comes out of it is continuous in wavelength. You see radiation or photons at every wavelength, and it has such a particular form. You can describe it by an equation that only depends on temperature. I mean, it's remarkable. You get order out of chaos. And this, is it not what has happened to life as it has evolved?
I think it's that sort of complexity is small beer compared with what you get in life, and I think it's just many, many orders of magnitude more complicated. If you think about the complexity of just one cell, let alone the trillions of cells which are in us, the complexity of the way the brain is wired up, the kidney, the heart, the way muscles work. But even a single cell, I recommend there's a wonderful animation which is prepared at Harvard University of the interior of a cell. I don't know whether you've seen it, but it's worth
I know what you're
Googling.
talking
It's
about.
absolutely fabulous thing.
The machinery, like you see molecules
That's right.
doing
There's
this, walking.
a sort of walking proteins.
I know, it's excuse me, it's incredible.
Along like that, and you say, if you're naive, you say, oh, there must be a God. There must be a God who done that. And what is so magnificent is the achievement of Darwin and his successors is to show that you can get that kind of complexity from nothing more than physics and natural selection.
But
And the way it works in embryology, it's, let me put it this way, you often read in biology textbooks that the DNA is a blueprint for a body, and it is not a blueprint. It's the last thing it is a blueprint. It's a program, it's a recipe. A blueprint would be something which has a direct sort of one-to-one mapping to the body itself. You could make a blueprint of a body by doing serial slices and putting into digital coordinates the picture of each slice. You could make babies that way, but it's not the way it's done. It's done by little local rules which are obeyed at the micro level. So at every stage during the development of an animal or a plant, little local rules are obeyed at the cellular level, within the cellular level, things go on locally on a small scale, and that all adds up in the end to the prodigious complexity of a body. So there never was a blueprint. DNA is not a blueprint. No blueprint exists. It's all done in the same kind of way as an ant's nest or a termite's nest is built by each little ant, each little termite, obeying little local rules. The local rules are quite simple, but they add up when you take all of them together to make a termite mound, which is not that complicated, or make a human body, which is just fantastically complicated. And that's achieved by natural selection. Natural selection chooses the DNA that controls these little local processes. But there is no blueprint. It never was designed either by God or even by natural selection.
So it works because it's just almost like nature does Monte Carlo, crapshoots. Like, let's...
Well, that's the mutation stage.
Yes, but natural selection working on mutations.
Yes.
And it takes lots and lots of these experiments. Some of them give the organism advantage in its environment. Others impede the organism or don't do anything at all. And the advantaged organism is the one that wins the day. And that's how this proceeds. It's just all these steps. And it seems like it is an incredibly inefficient process. The only reason why it works is because it's got all the time in the universe, right?
Yeah.
I mean, it's.
But it can go very fast sometimes. It's quite surprising how quickly it can go.
Well, it goes fast, though, only when you have an organism that only reproduces every, 30 seconds.
Well,
right?
Yes, and of course that helps, of course. But I mean, one rather spectacular example is the fish fauna of Lake Victoria.
The what?
The fish fauna of Lake Victoria, the cichlid fish, because we know that Lake Victoria is young, unlike the other great African lakes, Lake Malawi and Lake Tanganyika, which are very old. Lake Victoria is only about 100,000 years old, or maybe even less. And all the cichlid fish in Lake Victoria are descended from one ancestor, which got into Lake Victoria less than 100,000 years ago. And now there are thousands of different species, specializing in all sorts of different niches. And this takes place of the order of tens of thousands of years, not millions of years, which is, if that can be achieved in tens of thousands of years, think what can be achieved in hundreds of millions of years that actually have been available for the evolution of life.
So, but are you contesting the statement that, for an organism to evolve another adaptation to its environment, there had to be a lot of organisms that were tried and failed?
Oh, no, that's true. All I was saying is that it can be, that you said we've got plenty of time, and we have got plenty of time. We've got more time than we need. And
okay.
So Lake Victoria shows that we've got more time than we need.
Well, this is interesting because in my business there's this big debate about, how old does an environment like the ocean on Enceladus, how old does it have to be in order for us to at least find it reasonable that we could find life there? And a big deal is made about the fact that it took something like 300 million years. Well, it didn't take. We have an upper limit to how long it took life to evolve on Earth of something like 300 million years,
yes.
right? From when we think the environment on the surface of the Earth was quiescent enough so that if life got started, it didn't get wiped out with an incoming projectile that just blew everything away, to when you find the first fossil. It's something like the oldest fossil. That's something like 300 million years. So that's like the canonical number. Do we know that the ocean on Enceladus is 300 million years old? So some of my colleagues make a big deal about that, but I keep saying, and others keep saying, but we don't know how long it took life to evolve.
No.
That's just the upper limit.
Yes.
It could have, any thoughts on this? How long? How long did it take to get the first replicator? Could that have been?
Well,
brief?
as you say, with the first fossils we find are something under 4 billion years, so between 350 and 4 billion years. And the world was formed, what, 4.6 billion?
The Earth, well, yeah, something like that.
So it happened pretty quickly. It took a lot longer to get multicellular life, and even longer still to get the sort of life that's capable of being detected by a SETI program elsewhere. So it may be that the universe may be teeming with life of a bacterial kind, but life at our sort of level may be extremely rare.
Well, okay, so this, how contingent upon the geological history of the Earth is that timeline? I mean, it had to take multicellular life, do I have this right, started with oxygen. We needed oxygen, or did it create, I forget, how's that work?
I'm not sure we know that, because there are multicellular bacteria even.
Bacteria meaning they don't use oxygen? Is that
No,
what you're
no,
saying?
no. Sorry, many of them do. But I think you would say about 2 billion years, perhaps, to get multicellular life, and then to get really interesting multicellular life, like in the Cambrian, the sort of things that you recognize as being big animals. That was 600 million, something like that.
Incidentally, we were just talking about this before we came on stage. Yes, on stage. West of here is the Burgess Shale. Do you guys know that you live near the Burgess Shale? Okay. So, okay, but 2 billion years ago was about the same time of oxygen, oxygen event.
The really big breakthrough was the origin of the eukaryotic cell, where you had bacteria and archaea coming together and forming the sort of complex cell that is us and plants and fungi. And many biologists think that that was a huge step.
Before oxygen, there was not oxygen utilizing. They weren't.
Oxygen came with blue-green bacteria.
But does that precede the eukaryotes? Or?
Yes.
Oh, it does.
Yes.
Okay, so
yeah.
the eukaryotes were utilizing oxygen.
Yes. But blue-green bacteria discovered photosynthesis. And then blue-green bacteria got incorporated into eukaryotic cells of plants. And the green of plants, green plants, is made by the descendants of those blue-green bacteria, now called plastids. So our whole, both plants and animals, are borrowing the biochemistry of those bacteria, which came together in symbiosis about 2 billion years ago.
Why did it take so long? Or what's so special about that?
Maybe it took so long because it was a very, very improbable step. And that's what I'm saying, that maybe there are people who think that bacterial type life may be quite common, but the huge step was the formation of the eukaryotic cell. And then maybe another huge step was the formation of nervous systems. And it's quite interesting to look at the major steps which led up to the sort of complex life that we have today.
Okay, so maybe intelligent life is rare in the
yes,
universe.
in which case,
at least rarer than bacterial life.
Well, I'm sure of that, but
yes.
but
yeah, I guess I'm sure of that too. Even on this planet.
Perhaps we could talk about SETI a bit, because I've always been rather pessimistic about the possibility of finding any kind of life in the solar system. I've always thought the origin of life was rather an improbable event, but I was rather inspired by your suggestion of going back to Enceladus to look for presumably bacterial level kind of life. But I've always thought that the best prospect for detecting life was, well, the one foreshadowed in Carl Sagan's novel Contact, getting a radio signal from intelligent life somewhere, because you don't actually have to get the physical body. Radio waves travel the speed of light and in all directions, and so the idea of detecting life by listening out for radio signals does seem to me to be a serious possibility.
Well, you're not alone in this. So
yeah.
There's various thrusts in this business of searching for life, and us, we solar system people, of course, are concentrating on planets. Astronomers who look beyond the solar system are interested in looking at all the exoplanets that are being discovered by now at this point. I mean, do you know now that there are more planets in the solar system than there are stars? And because there are more, there's
more planets
I'm sorry,
in the
more,
universe, in the galaxy. Or
sorry, what did I say? There's more planets in the there's more planets in the Milky Way galaxy than there are stars. So we live in a universe teeming with planets, and those astronomers who look beyond the solar system are finding exoplanets. And they're interested in finding what they call Earth 2.0, and that is just a carbon copy of our planet, so that they can examine it spectroscopically, which means look at the chemistry of its atmosphere. And they are putting together what they would consider to be biosignatures, like what would they see in the spectrum of an exoplanet that would tell them that they found life. I think this is a very, very hard sell, because I don't know that they'll ever, not their fault, it's just the nature of the game, it's very difficult to separate to look at a chemical signature, even if you had a whole array of them, and know for certain that you've got the chemical signature of life when you're not really completely certain what the environment itself is. You're not there, and the environment can become more complex than you could imagine. So there is a camp of people who agree with you, and they think in the search for life outside the solar system, the real biosignature is going to be, if it should it ever happen, the interception of an intelligent signal. Yeah. And then you will know. So
can I ask first, can you distinguish spectroscopically, can you distinguish the chemistry of a planet from its star? Because I just thought the star would kind of swamp it.
Yes, because there would be things in a planet you wouldn't expect. Stars are hot, and planets are cold.
So you'd be looking for oxygen. That would be a pretty good telltale, wouldn't it?
Well, I say no, because oxygen can be produced abiotically, and people say, it disappears so quickly because it's used up by everything else around it, and so you wouldn't expect it to be there really. But you could happen upon something. You could be
free oxygen, not
free oxygen, yes, free oxygen. But you could happen upon a planet in a big state of disequilibrium. Our planet went through disequilibrium too. So it's going to be hard for exoplanet people to say with 100% confidence that they have found life. But the SETI people have a chance if they can find a signal, which brings us to the evolution of intelligence, which is something I wanted to talk to you about. So intelligence obviously is a result of increased complexity, right? Increased brain size and so on. And it's driven by a competition for resources and natural selection and so on. And I guess I first should ask you, I assume you think that natural selection and Darwinian evolution are universal, right? Is that basically the only way you can get evolution, or have you given any thought to this?
I wrote a paper some years ago called Universal Darwinism, in which I argued against Ernst Mayr was one of the great founding fathers.
Who?
Of Ernst Mayr, M-A-Y-R. One of the great founding fathers of the neo-Darwinian synthesis in the 1940s, the 30s and 40s and 50s. And he said that Lamarckian evolution, which is the idea of the pre-Darwinian idea of evolution, which was that of the Frenchman Lamarck, who suggested that evolution could be driven by two things, use and disuse. The more you use a bit of your body, the bigger it gets, or the better it gets. That's the principle of training. That's why you build up your muscles by training. And the second Lamarckian principle was inheritance of acquired characteristics. So he imagined a form of life in which those animals that strove, that worked hard, those individuals that worked hard to achieve something, built up those bits of the body which grew as a consequence of that, and then their children inherited it. Ernst Mayr said that there's nothing wrong with the Lamarckian theory, it's just that it isn't true. And I wanted to go further than that. I did go further than that. I said that even if it were true that acquired characteristics were inherited, which they're not, but even if it were true, then the theory is not a big enough theory to account for evolution. And the sort of way I put it was it's all very well talking about your muscles getting bigger when you train. That's true. And so if children inherited the enlarged muscles of a weightlifter, then you could get a form of Lamarckian evolution. But imagine doing the same thing for an eye, say. An eye is this immensely complicated, intricate piece of machinery which focuses light with a lens, an adjustable lens, on a retina of millions of light-sensitive cells, corrected for aberration, color vision, an iris diaphragm that opens and shuts as a light meter. You could not get that by the principle of use and disuse. You can't train your eye. The lens doesn't get clearer as a result of photons washing through it. The natural selection I argued, is the only way, certainly the only way that's ever been suggested, which could, in principle, give rise to evolution. So Meyer was wrong to say that the only thing wrong with Lamarckian evolution is the inheritance of acquired characteristics. It couldn't work, not even on any planet.
Okay, so no one's come up with any
and
better
nothing
substitute.
else. No one's come up with anything else. So the only other thing is design. And of course, there's enormous complexity of design on this Earth in man-made machines. Computers, cars, planes, watches. But they are simply, they're artifacts of life. So if you found something like a computer or a car on a planet, then you know that was life. It doesn't have to, it's not living itself, but it's diagnostic of life. So natural selection, or the products of natural selection, are I think the only way you could get the orders of magnitude more complex things.
Okay,
to life.
so then, A leads to B, leads to C. Intelligence evolved on this planet.
I think yes.
We should expect it elsewhere in the universe.
Yes, but I think that intelligence, complicated nervous systems, evolved as a result of what I call evolutionary arms races. Some of evolution is just about adapting to changing climate. Say, when there's an ice age, natural selection favors thick, shaggy coats, and when it's hot, it favors losing them. But that doesn't give rise to the enormous levels of complexity which we're now talking about. What does that is arms races. The arms race between, say, predators and prey. Adapting to the weather is one thing. Adapting to the climate is one thing. Adapting to predators is another. That's where complicated eyes come from, ears come from, running limbs, flying wings. These all come from the need to outwit and outpace predators, prey, parasites, hosts.
And this argument makes quite clear. The only ones who, it was only those organisms that had those capabilities that lived to reproduce. And
Exactly,
that's how it was.
yes,
Okay,
yes.
continue.
And so all the sort of complicated evolution that we see is a result of arms races. And then there's simple evolution as a result of adapting to things like rainfall and
Okay, but
the difference between a predator and the climate is that the predator is out to get you, and the climate merely is inconvenient.
right. So it puts a finer point on it.
Yes, yeah.
Okay.
And the predators are getting better at it all the time. That's the point.
Okay. So intelligence obviously conveyed an advantage to surviving. Okay, which is why it's done so well. That's why.
Yes, I suppose. I mean, you have to point out that there are not that many. I mean, we're the only species that even comes close to the sort of intelligence you'd need to be detected by a SETI listener on another planet.
Okay, but still, the point is that intelligence, it seems to me, when I look at Homo sapiens, is a double-edged sword. It helps us cooperate, right? I'm assuming it's part of the reason why we cooperate. Is that a correct statement? Are there organisms less intelligent that cooperate? I guess they
Oh, yeah,
do.
oh, sure. I mean,
Yeah.
social insects, for example.
Insects, okay. Okay. It just seems to me that through intelligence, we're able to, I want to put, it may not be correct, I want to say, along with intelligence and all the wonderful things like cars and computers and spacecraft, come the ability to be capriciously violent towards our own kind.
Well, one of the arguments for why the answer to the Fermi paradox, where are they? Why don't we?
They killed
each other. It could be that all over the universe there are little islands of intelligent life winking into existence and then winking out again as they destroy themselves. Maybe there's a brief window of opportunity between the arrival of technological expertise and then the self-destruction by that technological expertise.
This is where I'm going with this. I'm wondering if that's going to be inevitable, our own destruction, because we can't consistently work together for a common goal. And then on top of this is something you and I have spoken about. I don't even know which book of Jared Diamond's it appeared in, but he wrote a book. Jared Diamond's is an anthropologist, and he said that the size of our brains limits the number of relationships that we can keep track of. And for the brain the size of ours, it's about 150, I think, is the number. So we are limited to the number of people we can have relationships with and I guess feel some kinship for, even if they're not our genetic kin. Or I don't know what
that's called the Dunbar number, yes.
Okay, so put that together with the fact that intelligence has not only the good side but the bad side. Maybe it's not surprising that we can't come up with a global, a unified global response to climate change or species extinction, because it's just, we're not capable of it. We're literally not capable of it. We're asking too much.
It's already very astonishing, though, that we are capable of doing so much, given that natural selection bred us on the African savannah to hunt and gather and avoid being eaten by lions.
Yeah, but they didn't have to do that in Africa and in Canada and the US and Indonesia.
The fact that having been bred for that, we are now capable of developing quantum theory and
how many people work in quantum theory? I bet it's less than 150.
Well, yes, sure enough, but nevertheless.
You're missing my point. You're missing
mine.
Okay, go ahead. I'll let you go first.
I do think it's a genuine mystery that the human mind, admittedly only a very few human minds, but there are human minds which, as far as natural selection is concerned, were only ever bred to hunt and gather and avoid being eaten by lions. Nevertheless, that brain power is capable of producing an Einstein and a Max Planck. And never mind about Einstein and Max Planck, I mean just people capable of designing rockets that can take you to Saturn.
I'm in awe of that as much as you are, but I'm saying that is obviously not translated to large groups of people being able to see each other instead of as one tribe against the other tribe,
that's a terrible truth, and I agree with that.
It's the terrible truth.
You said maybe it's inevitable. I mean, we've got to try to evit it as far as we possibly can.
I agree with that, but I'm just posing the question, Richard, that I think let's discuss this. Are we asking too much? Could we possibly be asking too much? It's just we're not capable of doing it. And this gets into my feeling, this segues to the next thing. I'll just jump to it right now. There are those people who think that it is absurdly dangerous and irresponsible to send messages to the cosmos, like Frank Drake did in 1964 with the message he sent from the newly refurbished Arecibo telescope, the biggest radio transmitter in the world. And he sent a message, basically, I forget what the message said, it described what a human was, really simple, it was just kilobytes in size. And others have tried this, and Carl Sagan and his collaborators put a message on Voyager. These kinds of things I just love. But there are those people who are just hell-bent on claiming that this is irresponsible because we should not be advertising to the galaxy where we are, because we don't know that aliens would look at us benignly and they could come and destroy us.
No, that's right, but
That's right?
Well, no, sorry. No. I don't think that's right. I mean, I'm just saying that that's right. That's what they say.
No.
I've never really been worried by that, because it's one thing for radio waves to go out, but then actually coming here
Is ridiculous.
Yes. So I don't worry about that.
Okay, so this is my take on this. It would require so much effort
Yeah.
to mount that kind of expedition,
Yes.
and to do so with capabilities for, you'd have to be seeking to destroy whatever it is you find.
Yes.
In order to.
Now, there is one way it could happen, and this was the way that Carl Sagan raised in his science fiction novel, and Fred Hoyle also in his novel A for Andromeda, where you don't actually come physically. You send a radio signal and tell us to build a computer, which then does its bidding. I mean, that's the only way it could happen, I think.
Okay.
I mean, that was the Carl Sagan plot.
Okay, well, anyway.
You don't have to come physically, in other words.
Okay, but I'm still saying, though, that to do that, by the way, to even send a radio signal that could be that powerful requires a lot.
Yes.
A lot of, capability on the host, on the planet that's doing that. But I'm saying that not only does it take effort to do that, but I'm wondering if intelligent civilizations, you said it already, if intelligent civilizations even live long enough to get to that stage. So I'm not paranoid about, evil aliens coming to get us. It sounds, to have that kind of paranoia sounds almost like the vision statement of the National Rifle Association. So I think we have probably another 10 minutes. I don't know, we were supposed to get some kind of signal, but let's see, what should we talk about? So here, let's talk about the 7 minutes. Okay, very precise. So I have a topic here. One of my last ones is the future of life on Earth. It looks bleak. So let me just read my little preamble here. I think our tremendous success at surviving and even improving on evolution has come to us at tremendous cost. Life forms are becoming extinct all over the planet. There's a horrific loss of insect life. I've just only read this over the last several decades. There's been drops ranging from 50% to factors of 60, which is a drop of 98%, depending on the species of insect and where you're talking about on the globe. And this, of course, brings about the consequent loss of insect-eating species. Insects are the planet's custodians. They're the ones that, keep it in good working order. They're going away. And there's no end of bad news about macro species either, like elephants and rhinos and cats. I mean, it's unbelievably depressing. And of course, disastrous and maybe irreversible changes to the climate. So as someone who's devoted himself to wanting to understand life on Earth, how do you feel about this?
I feel very much the same way, and I, subscribe to these elephant charities and things like that. It's partly an aesthetic thing. I mean, some people say, oh, well, species have always gone extinct, and the great majority have gone extinct, and so on, and I don't warm to that at all. I mean, I think that when a species like the African elephant, say, if it goes extinct, it's a major tragedy. I would love to see genetic engineers bring back the woolly mammoth and the thylacine from Tasmania, and actually Neanderthal man I'd like to see brought back as well, but that's more controversial. I have a very, very strong aesthetic judgment in the same way as you have. I think that the rise of humanity over an astonishingly short time historically, it can be seen as like a major plague on the Earth.
We're the primary invasive species.
Yes. On the other hand, some of my friends and colleagues, Matt Ridley and Steven Pinker, for example, are somewhat lone voices crying in the wilderness, but they are optimists who've written books. Steven Pinker's, 2 books, The Better Angels of Our Nature and Enlightenment Now, which only just come out, and Matt Ridley's The Rational Optimist, who have enormous faith in the power of science to conquer the problems that are going to arise. They don't deny that these problems are arising and will increase, but they also point to the enormous success historically of science in solving problems. And so I don't know where I stand on that. I would like to believe the optimists if I could.
Well, I know a lot of this discussion about how, Steve Pinker talks about how great things are and we shouldn't, despite how we look at things and see they're so bad that really they're better. But oftentimes all those kinds of discussions are aimed at human life. It's better for human life than we tend to think of it. But I think losing the damage we're bringing about to the biosphere, if you're going to be human-centric, could have bad consequences for us that we're not even able to divine right now.
Yes.
So, and this is why I keep thinking about, do we really have it in us to solve global problems like this, or, is it just beyond what we're capable of doing? But anyway, that's kind of a depressing note, but I guess we'll stop there. Is it time? Yeah, okay.
Can we have the lights up then?
So I think we're going to go into a question and answer period now. Thank you. Wow, all the way up there.
Am I audible?
Yep.
Yes.
Professor Dawkins, is there any hopes in the future of you helping us establish more debates, such as when you were in Sydney with Cardinal George Pell, or on Al Jazeera, or Sam Harris with William Lane Craig? Can we see any of those in the future coming? And on a side note, is your wife still painting your ties? And for Carolyn, on the side note, with all your experience coming to you in the last 3 decades, can you imagine some way of interstellar travel that you could see in the future? Thank you.
Well, this tie is one of Lala's, and I have many more. I've also got a new source of ties, which is a young Italian artist who hand paints ties. His name is Leonardo. And I've got 3 of his ties. Debates, I don't actually like the debate format very much. Obviously you do. I don't think I'm bad at it, but I'm not very good at it either. And I'm not sure that it's the best way to get at the truth. Because there are some people with great rhetorical skills who are talking absolute nonsense, and they get... You trust George Pell. Well, but George Pell, well, he was described to me as a bit of a bruiser, which he is. He's been in a bit of trouble now, isn't he, I think? Yeah. But I don't do Schadenfreude. I think one of the problems with having debates with creationists is that often they have their own audience there, and the audience doesn't really know any better than to be snowed by the false arguments which are being put. So I don't do debates with creationists. I do sometimes do them with so-called sophisticated theologians. My colleague, the Australian biologist physicist Robert May, who became the president of the Royal Society, a very distinguished scientist, he's got a good answer to when he's invited to have a debate with a creationist. He says, "That would look good on your CV, not so good on mine."
The interstellar question, you're going to be surprised at this, but I'm not in favor of interstellar travel because I don't think there's a good purpose for it. I haven't heard anyone articulate a really good reason why we need to go and find another planet to live on. If we had those kind of resources, we should fix the one we're on now. That's how I feel about it. And as long as you've given me the opportunity, can I just elaborate a little bit more on this? We'll take everybody's questions. I just want to point out that, I mean, it may be obvious, but it may bear stating anyway, that how would interstellar travel happen when you're talking about actually sending people and not our robots? Maybe there would be a party of 100, maybe 1,000 even people that we would put in a spaceship. Probably we'd have to figure out a way to get close to the speed of light in order to make this even feasible. We don't know that that's even physically possible. But let's say we do that and we send them off and then we bid them goodbye, and maybe for some period of time we hear from them, just the way we hear from spacecraft, like Voyager is, out in the interstellar medium right now we hear from it. But eventually they will be out of reach, right? Because we'll get older and older, they'll get further away, the light travel time will make it so that you never hear from them. They'll be notional. Maybe you'll be, in the morning washing your hands, shaving, and you'll be thinking, oh yeah, there's that party of, people we sent out. Humanity 2.0, and you'll think about them and that's it. You'll go about your life, which is to say it will matter not a whit.
I shall argue with Carolyn on this.
I'm not done.
Not now.
I'm not done though.
No, not now. We've got 2 more gigs to do. One in Memphis and one in Dallas. And so
Dallas and Nashville.
Nashville, that's right, Nashville. So we shall take this up there, okay?
Okay. All right, well, but you heard my take on it. I want to fix this planet first.
Does that mean I'm up?
Yep.
What a pleasure to be in the same room, Professor Dawkins, as you. I'm a little disappointed. I wore my blue shoes. Or socks, I mean. Because you were so famous in wearing those multicolored socks of yours. I wanted to thank you very much for the intention you have of writing a child's book to help children understand that woo-woo is not necessarily reality. And I'm hoping that one day that will come out.
The answer to your question is yes.
Okay, I hope very soon.
Yes.
My question, though, is this, that you're here in Canada. CFI doesn't seem to know where Canada is, because when they outlined all of your speaking engagements, this one was not on the list. But having said that, you're in Canada, and as you know...
You noticed.
Yes, we've noticed. We hope the rest of you do. But here we have an issue that came up a number of weeks ago with an event with Chrystia Freeland. And she and our Prime Minister took to task the Arabian prince, Crown Prince, with his issue of incarcerating Rafi Badawi. Have I got that right?
I think Raif Badawi is his name.
Raif Badawi and his sister. And there isn't a nation on the planet that supported Canada in that initiative. I'm sorry, who?
What's the question?
And the question is, and now we're finding that the same Crown Prince was probably involved with a premeditated murder. No, I have no intention of saying that. Involved with a premeditated murder of a reporter.
Obviously, Carolyn and I both deplore it very heartily. That's the answer to your question.
Anything about it.
Okay.
Test. Okay, this does work, actually. Carolyn, I would just like to say I was actually here for your talk. I think you're brilliant.
Thank you.
I think she should deserve a round of applause. She is very brilliant. If you don't know who Voyager or Cassini is, please look it up. It's actually very lovely. So my question for you.
Thank you very much. I was beginning to feel like chopped liver.
I had to educate a few people. I'm like, do you know what Cassini is and Voyager? I'm like, oh, okay. This is why I'm no longer allowed at parties. So my question for you would be, I'm very startled being in a little bit of the spotlight, sorry.
You're doing okay.
Thanks. It would be, do you think that should we explore life in one of Saturn's moons instead of Mars?
Yes. Yes.
With Mars, you're going to have a lot of the radiation, there's some things.
No, Mars is not a radiation issue. And Europa is a radiation issue. And we decided to send a spacecraft to Europa because that was all we had, so to speak, before we got to Saturn with Cassini. But then we found Enceladus, and Enceladus is just so much better for doing that kind of observation, going to look for biosignatures than Europa is. But even Mars, the surface of Mars is toxic also for a different reason, having to do with ultraviolet radiation. There's nothing that prevents ultraviolet radiation from getting down on the surface, and any life there is going to be subsurface, and so you have to dig for it. And so, and then also we just recently found the surface is covered with this salt called perchlorate, which is like the most saline thing we know of, and life can't live in extreme salinity. So, we started going to Mars, and the whole program got started. And so it's like momentum. We're still doing it, and it's just been difficult. We found organic materials. They finally have found large organic molecules a few inches below the surface of Mars, but they can't tell you whether or not, they just don't know. It's not like they're hiding it. It's not known whether those are molecules that were delivered on the backs of meteorites, or they were produced abiotically, which means without biology, or they are the remnants of former organisms. We just don't know. I want to say, though, we don't know that we're going to go to Enceladus with the right kind of experiments and find life there either. We just don't know. I mean, there's no promises in this. It's just right now promising. Very promising.
Thank you very much.
Thank you. Thank you. Over here.
So during one of your Christmas lectures, you had described life as being a brief moment in the spotlight. And what I was wondering from both of you is if you could tell me, during your brief moment in the spotlight, what has brought you the most joy?
Well,
that's you. I didn't give any Christmas lectures.
No, I didn't. But you've had you're a star in the spotlight. So. Let me explain. Let me explain. I was trying to make the point that in the sweep of time, the time that we live is extremely small, and I use the analogy of a spotlight moving along a great ruler of time.
Oh.
And so it was almost the probability of your being alive is extremely low because the vast majority of time you're dead before you're born and then dead after you're dead. So he's fishing for us to say something about the greatest joy we've had in our brief moment in the sun.
You go first.
I was hoping you'd go first.
All right, I'll go first. I feel like I have led a charmed existence, and I mean that. I say this all the time, because of what I got to do in life. I was on the Voyager project, which was the most far-reaching, most historically significant, and most iconic mission of them all. And I don't think it's hyperbole to say that Voyager was the Apollo 11 of the planetary program. That's how significant it was, and also it has that kind of status in the imagination of the public. So I was on that project, And then immediately after that, I was chosen to lead the imaging team on Cassini, two of the most profoundly successful missions of all. And, you know, it's really true that I have felt, and this is common in our business, I felt that I was an explorer actually there. You know, I know all I did for 3 decades was sit in front of my computer terminal typing, but it didn't feel that way up here. Up here, I was living on Saturn, and I got to be part of, not only be alive like all of you were at a time when we did this, but I was lucky enough to be part of that and even lead the team of scientists who were the documentarians of our travels at Saturn. So, I mean, you know, it was rough. I'm not going to lie. It was actually a very, very tough job, very demanding. But I know when I die, I will know that I had lived my life in probably the most significant, meaningful way that I could have. Yeah. So that gives me a lot of joy.
I agree. Yes, I think that during the short time that we have, for me, the privilege of being allowed to understand why I exist in the first place, which is what an evolutionary biologist does. I mean, it's an astonishing thing to say, here we are, it's as though we've just woken up. It's imagine that you were transported to another planet, and you stumble out of the spaceship, and you find yourself surrounded by all sorts of weird and beautiful things, alien things. That's the situation we're in when we're born. We don't stumble out of a spaceship, we stumble out of our mother. But if you think of it like that, then it's an amazing privilege to live on this planet and to be born at a time when we very largely understand the process that brought us here, the process of evolution from bare physics up through the billions of years of evolution to give rise to us. And it's only really in the last couple of centuries that it's been possible to say that, and the pace is accelerating. And so as a biologist, although my feet have been on the ground, so to speak, I haven't been to Saturn, I feel a similar kind of excitement to the kind of life that I have led as an evolutionary biologist.
Richard, I'm a member of the Clergy Project, so thank you for your role in
that. Deserves a round of applause.
There's 2 others of us here tonight. I'm very new to this, so I'm wondering, how did you meet, this Four Horsemen thing? How did you guys get together? Did you know each other beforehand? What was the connection? How did you guys bubble up to be the Four Horsemen?
Well, let me first of all say a little bit about the Clergy Project, which you're on. This was a project which we started some years ago to help people in the clergy to free themselves from the yoke that they were under and to find an alternative life. And so congratulations on being a member of the Clergy Project. The Four Horsemen, well, that's an accident. I mean, we never called ourselves the Four Horsemen. We just wrote books at roughly the same time, without collaborating or conspiring together or anything like that. We just wrote our books. We had a meeting, the only time we ever met as 4 people together in the same room, in Washington, D.C., in Christopher Hitchens' flat, and recorded that, and it's available on our website, Richard Dawkins Foundation website. But it's also, we're just about to publish a transcript of that entire discussion. And the book is to be called The Four Horsemen, and it has new essays by the 3 of us who survive, plus a new foreword by Stephen Fry. So that's going to be available, I think, anytime now.
So, of course, I want to start by thanking you very much for joining us, but also wanted to quickly say it's so great to be in a room with all of you as well, people who share the same interests, so thank you all very much. I appreciated the time spent on describing the similarities and differences between Lamarckian and Darwinian evolution, and I was hoping you could touch briefly upon epigenetics, the way that the environment expresses genes, expression, and even transcription, and more broadly in terms of scientific communication? How do you go about explaining these sort of processes to a public audience? Because I've seen far too many advertisements for epigenetic yoga, and I think that has to be wrong.
Epigenetics is the flavor of the, I almost said month, I'd rather say week. What epigenetics actually is the differential turning on of some genes rather than others. So epigenetics happens all the time in embryology, in development. You start with an egg, it splits, and then you get different tissues developing. Different genes get turned on. So in any one cell, only a minority of genes get turned on. Others are switched off. That is epigenetics. Now, it's become a vogue word to mean something rather different, which is a kind of pseudo-Lamarckism, which is a passing on to subsequent generations of which genes are turned on and which genes are not. So it may happen, it may occasionally happen. It's not a big phenomenon, it's not a very important phenomenon. What is an important phenomenon is epigenetic differentiation within the embryology of every one of us when we were in our mother's womb. But the vogue word epigenetics, which has now been taken to mean a kind of neo-Lamarckism, is overrated and needs to be put in its place.
Hello?
Yes,
Hello?
we can hear you.
Oh, awesome. Thank you both for coming. I don't know how long you're in Calgary for, but I definitely recommend checking out the Royal Tyrrell Museum
I've
in
been there.
Drumheller. Okay,
Been
excellent.
there, done that.
Awesome. Okay, cool.
I've got a really cool picture of myself standing in front of that dinosaur on the outside.
Oh, hell yeah, nice. Yeah.
on my
Did you go
web-
up top?
No.
Oh, it shakes. Like,
Okay.
just don't jump. So, Professor Dawkins, you said the only other option is design. Are we in a simulation?
Sorry. What did you say?
Are we in a simulation?
Oh,
Like an ancestor simulation.
are we in a simulation? I mean, there is a theory which I first of all met in a science fiction book by Daniel F. Galloy called Counterfeit World, which suggested that yes, we are indeed in a simulation, and that has been revived more recently by Max Tegmark, I think. Is that right? The cosmologist Max Tegmark? Sorry?
And Elon Musk.
No.
That's what he said.
Really? Oh, maybe. Okay, maybe Elon Musk. And I think Max Tegmark. Have I got it right? No, it's not him. It's Nick Bostrom. That's the one. Nick Bostrom. He thinks that future humans will have developed the technology to simulate us. And so he thinks that we are in a simulation done by our remote descendants of the future. And he makes the point that we couldn't disprove that. But yeah, well, I'm open to all new ideas.
Okay.
Okay, thank you.
I just have just a nice question. Unfortunately, I became an atheist 2 years after Christopher Hitchens passed away, so I was just wondering if you would share a particular memory of Hitch that you wanted to share with us.
Did you know him, Carolyn?
I had only met him. I met him.
I mean, I wasn't a close friend of his. I also only met him sort of after our books on atheism were published. I admired him enormously. I thought he was, in many ways, the finest orator I ever heard, because he not only had a very good voice, but he also had an enormous store of erudition and knowledge, and was able to come out with facts at command whenever he needed them. So he was a very, very effective debater. I once wrote a blurb for one of his books saying, if you're invited to have a debate against Christopher Hitchens, decline. He's a very tragic loss. I didn't agree with him on everything. He was had very different views on abortion, for example, from what I hold, and on the Iraq War, of course.
And he made some ridiculous statement about how women aren't inherently funny.
That's right, yes. I think he was a contrarian, although he explicitly denied it. And I particularly enjoyed his answer to the free will question, which I hope we don't get tonight. And when he was asked whether he had free will, he said, "I have no choice."
Thanks.
Richard, my question was very similar to the last gentleman's, but I became very interested in I'll say your friend and colleague Christopher Hitchens some time ago, and was astonished at his knowledge and skills of evolution versus creation. And I'm curious about your first meeting with him and what you talked about.
Well, I met him backstage when we were going to go on as a debate together in London. And that debate that occasion was notable because he was the subject of a false memory, I think a most dramatic false memory, in which we were debating against three theologians, and one of the theologians said something silly, and Christopher said, "How dare you? How dare you?" Only he didn't. And that was the false memory. And what actually happened was that much later, a question from the audience provoked him to say that. What the woman on the platform said was also silly, but not that silly, and his reaction to it was not actually audible. Now I discovered my false memory by watching the YouTube video of the occasion, which proved absolutely conclusively that I was wrong in remembering when he said, "How dare you?" Well, that's not particularly remarkable. False memory syndrome is a well-known phenomenon. What is remarkable is that I then later met Anthony Grayling, who was also at the debate on my side, sitting next to me. And when I told him this story, because I thought he'd be interested in false memory, and his jaw dropped, he said, "But I have exactly the same false memory."
Thank you, Richard. I do recall that YouTube as well. Thank you.
No need to applaud every answer.
So, Mr. Dawkins, I have a question. What do you think of the what I would call egalitarian/true atheist argument that there is no God or gods or devil or devils or whatever, what have thee, if only because there couldn't be, for we are all equal, though we are not the same, no exceptions or exemptions, period?
I don't really get the argument. Why could there not be a God just because we're equal? I don't get that.
Well, like for example, in Star Trek, Captain Picard says to Q, "You are not God." Right? The whole premise would be, the whole nature of the argument is, it doesn't matter if this or that would have whatever quote-unquote supernatural powers, if only because, well, we are all equal or we are not the same.
I may be the only person in the room who's
matter.
never seen Star Trek. Carolyn, you've seen Star Trek. Can you answer that?
Can I answer this? It sounds like you're asking Richard what his opinion is of an argument that if we're all equal, there can't be a God, because then that means we're all God. Is that
Exactly. In a sense.
It's a stupid argument.
Doesn't sound like a good argument to me.
No, it doesn't.
Well, yes.
There's better reasons to dismiss the existence of God
Well,
than that.
of course, but I'm just asking with that particular argument.
I think we answered, right? Didn't we?
Yeah.
Okay. All right. Thank you.
Hello.
Hello.
First of all, I think we all agree that Richard Dawkins is has one of the most beautiful minds of this past century. And so my question relates to...
Wow.
Well, let's give him a round of applause first.
Come on.
My question is about consciousness in terms of an evolutionary sense, and then specifically bioentanglement, and the idea that biological organisms follow the same kind of processes that you find in quantum entanglement, and the idea of like non-locality in terms of obtaining information faster than the speed of light. Does that make sense?
I was about to say I don't do consciousness, but I'd rather do consciousness than quantum entanglement, I think, because...
No. He said bioentanglement. Bioentanglement. The biological organisms do a similar thing.
Yes, but are you talking about Roger Penrose and no, what?
I'm talking about, even in RNA, there's entanglement there. There's physics that, just simply the quantum entanglement between the spin of two photons, when you can separate them between, let's say, a galaxy, and if you change the spin of one, you change the spin of the other.
So are you saying that quantum entanglement might have some relevance to biology?
I'm saying that consciousness, and I know you hate consciousness.
No. No, I think you're talking about Roger Penrose's idea.
I'm not sure.
What is Roger Penrose's idea?
Well, he thinks that consciousness is not explicable by the ordinary sort of data handling models of computers and things like that, and that something mysterious is going on in neurons to do with quantum theory. And obviously I don't understand it.
Can I ask you a quick question? Are you familiar with synesthesia?
With who?
Synesthesia.
Oh yes, but I don't think that's nothing to do with quantum
What is
entanglement.
synesthesia?
Synesthesia is when your senses get confused and
a blending of the senses.
And you hear colors.
What about Niels Bohr when he said that there is a spirit, a community of spirit, and when he was talking about Neil deGrasse Tyson talking about... All right, yeah. Sorry, guys. I know, I only ask it because you're coming up to a conference with Brian Greene coming up here November the 1st.
I think we're talking about a lot of different things here. I mean...
But just in like the specific bioentanglement sense, if it's 1% chance that there's other dimensions outside of space and time, and if you look at an event horizon, when you reach the event horizon of a black hole, there is no time.
Really,
is it not worth investigating, even if it's worth 1%?
I think this is a kind of just a whole lot of sciencey sounding words that don't have much connection with each other. And I'm sorry.
I think we better go on to the other questions. Okay. We have to be done in about 6 minutes. Okay.
My question is, how did you guys pick your careers? Was it really easy for you, or did you have a lot of interests? And how does someone who's like 20, 30, 40 go through that decision?
In my case, it was starting off pretty much as an accident, but it was an accident I'm delighted that it happened. I didn't plan it. It just sort of, I drifted into it and couldn't be happier that that's where I ended up.
And in my case, I just have always, ever since I can remember, been very curious about the natural world. So I took I just did science, even as a young kid, just went in that direction. And eventually I realized I was interested in space and astronomy, and that actually started with more of a religious quest, trying to, what I call an existential crisis, trying to understand at the age of about 13 what was the meaning of my life and what was I doing here. I don't know how many went through that stage when you're a young teenager, you're trying to make sense of the world and yourself. And that basically evolved into, okay, well, where is here? And I turned to astronomy, and I feel the same way. I just never had any question Was not one of these people who was torn, oh, do I want to write? Do I want to go into medicine? It was just, I always just did what I, followed this drive. So I don't know what to advise people who don't really know what to do. But I'm just telling you that, like Richard, I just feel like having spent my life as a scientist is hands down the most interesting thing you could do with your time.
Just wanted to say it's an incredible privilege to be in the room with both of you and listen to you tonight. Thank you. My question for Professor Dawkins, of any arguments or discussions you've ever had with any theologians, wondering which one would you consider to be the most sophisticated? And also curious for Professor Porco, wondering if you have any insights on the latest news from the climate change being much worse in the next century than that just came out recently. What would be the best technology or science and research that is currently being done that would provide some hope for that?
Okay, you want to go first, Richard?
The most sophisticated doesn't mean the most valid, of course. And I have never come across any good argument from a theologian of any kind. Some may sound sophisticated, but that often is because there's really nothing there, and it may sound complicated and it may sound difficult, but I think it's either non-existent or empty.
Okay. And obviously, I'm incredibly alarmed, but frankly not surprised that things are worse than we had been, told whatever 10 years ago, 5 years ago, because in those past announcements of the status, where we were in the climate change situation, there was always, scientists always said, well, we've modeled A, B, C, and D. These are the 5 scenarios. It could go in this direction under these assumptions. This would be the worst under those assumptions. But, mind you, we don't really know what methane in the permafrost, what effect that will have, and we don't know this, we don't know this. And so now we're finding it's much worse. And I just heard, I don't know if it's true, but I heard someone who's a noted climate journalist say that we have now put so much CO2 into the atmosphere that we could even prevent, or it would dominate the Milankovitch cycle. So in about, don't quote me, something like 10,000, maybe it's 20,000 years, we'll go through another ice age. That would be what would return ice to the poles, assuming we lose it all, right? But we've put enough CO2 into the atmosphere already that it might possibly prevent that from happening. So it's very, very serious. And I knew even before that announcement was made, just reading the Paris, not the Paris Accord, reading a book that was produced by, it was a combined effort from the Royal Society in England and the National Academies of Science here. And it said, its last statement was basically that we've already put enough CO2 in the atmosphere that even if we brought down emissions, what did I say? Did I
Nothing knows my stupid alarm.
Oh, I thought I missed. If you put CO2 into the atmosphere, that if we brought emissions down to 0 now, the sea levels are still going to rise somewhat, still going to get hotter. So it's been clear to me for a while, it's even more clear now, that what we have to do is remove CO2 from the atmosphere. Bring emissions down as close to 0 as we can, and remove CO2 from the atmosphere. Okay, I just have this feeling, like I said already, I'm not sure we're up to it because it has to be done globally. You got to get China to do it. You got to get Africa. You got to get all the developing countries that want to live the lifestyles that we live. You got to get them to do it.
You've got to get rid of a president who says it's a hoax.
Well, but you're kind of making my point. How did he get there? He wasn't elected. Our election was hacked. That's why he's there. Okay, so
yeah.
we're facing enormous, enormous problems. And But you ask me what technologies, everyone thinks technology is going to be the answer. It's not the only answer. We have to have, political will behind it, but we have to remove CO2. That's what we have to do.
For your inspiration.
How much longer we...
One, is it the last? Somebody say last question.
Okay, so I guess it's over here. I'm sorry to...
Yeah.
Hello.
Hello.
My question is for the both of you. I've heard there's an opinion going around that science and religion can't coexist in a professional laboratory, for example. Do you think that's true? And if you do, what is the branch of science that can work the closest with religion, if you know what I mean?
The closest what?
What is the branch of science that can potentially work the closest with religion?
Well, in one sense, they must be compatible because there are individual humans who manage to do both. But I don't find that a very profound answer. I believe there is a very, very deep incompatibility, and that's perhaps more so as a biologist even than a physicist, because biologists are constantly aware of having an explanation for the existence of massive complexity which doesn't involve any kind of intelligence or creative design. And so if you have if you're a scientist who believes that in spite of all your science there is a creator too, then as it were you've betrayed the entire scientific enterprise because you've undercut the whole massive enterprise of explaining things. You've smuggled in a non-explanation at the very place where you ought to have an explanation. And so I believe that science and belief in God anyway, some people define religion differently, it's just, thinking beautiful thoughts and things like that. That's fine. But religion in the sense of believing in a supernatural creator of the universe, the laws of physics, biology, whatever, that I believe is deeply and fundamentally incompatible with science.
I agree. One more? 10 more? We're going to do 10 more minutes. Okay, so, yes. Okay, go ahead.
That's great, Okay, Professor Porco, I recall you saying that you feel you've spent so much of your life looking up into the universe, it's sometimes hard to keep up with what's happening here on Earth. Do you think influential women scientists have a responsibility to address gendered social issues within the scientific community? Or should it be acceptable to stay quiet and maintain their focus on major scientific work as is a male scientist's privilege? And are you annoyed by questions centered around your gender instead of your remarkable scientific work?
Well, I'm annoyed that these issues exist. I'm certainly, it's hard to believe it's 2018 and we've just gone backwards in this thing. I don't make a big deal about it. I don't want to, here's the thing about it. I know why women want to talk about women in science. I get it. They want to just, for the next generation, they want to show, look, you can do this, and it will be empowering to them. It probably would have made a big difference to me, or would have helped more to have had women role models when I was young, because I didn't. But for those of us who are held up as poster children, it's actually not such a good thing, because I feel that it kind of cuts my accomplishments in half. It's like saying, we're going to hold you up as a woman in science. We're going to make this arena over here. There's all these women, and you're a woman in science, and you've done great that way. And I feel, well, damn it, I was here with the big boys over here in the big arena, and, I kicked butt.
Hear, hear.
You didn't really have to do that, but it's okay. I'm not trying to pat myself on the back. I'm just trying to make a point that You know, Morgan Freeman, I think, said a similar thing when I think he was asked, you know, how do you feel about being a successful black actor? He said, I'm not a successful black actor, I'm a successful actor. Yes. And I feel that way. I feel like I'm a scientist, damn it, forget my gender. If you're calling out my gender, you're undermining the very thing we're trying to you're calling out the very thing we're trying to get rid of. So
Precisely.
It's a double, I get both sides. I get that young girls need role models. But, you know, for the people who are held up in this way, it's kind of irritating. And I'm not the only one who feels this way. So I would say to women in science, you know, if you want to hold conferences with, you know, have lots of women speak or all women speak, do it. Just don't talk about it. Just, you know, or better yet, you know, make sure you have women and throw in men too, just to prove that, you know, oh, here's the other thing. Oh, you're going to get me started on this. Here's the other thing that's a little bit irritating. And, you know, we say to men, you've excluded us, damn it, all this time. You know, God knows you're making deals, you know, in the men's bathroom. We're excluded from that, you know, and so on. But to say, oh, we're going to just have women in science and all these groups of women are going to get together, it kind of excludes them. We're kind of doing exactly what we said that they did that got us angry. So, you know, I don't know what to say, what the solution is, except just, you know, keep on keeping on. And just, you know, I think that the rules are in place. I've said this also a lot. The strategic battle has been won. The rules are generally in place. Women have to be, their proposals have to be reviewed. People go out of their way to make sure that, you know, we're looking at female candidates for a job as well as male candidates for a job. So I think we've made large progress there. Still, I think that the battle is the tactical battle. When you're around a table and, you know, there's mostly men and you're the only female, it can be intimidating to offer your opinion, knowing that chances are you're going to get dissed. You know, no one's going to pay attention. So, I mean, I don't know what else more to say about this. I mean, I get it. I get it, but I'd rather you not do it for me. I'm a scientist. That's what I am.
Okay, I hope one day we don't have to talk about it. Thank you so much. Have a great night.
Okay.
Both of you have studied networks on the cosmological scale and on the biological scale. What would you, from each side, apply to how humans interact with our environment around us that would make the world a better place?
Are you talking about like the biosphere? Is that what you mean? I just regard it, just respect it. You know, just don't bulldoze everything down. You know, limit the population. You know, that's a serious thing we have to contend with. There's too many of us. When I was born, which is a long time ago now, there were 2.7 billion people on the planet. Okay, now there's 7 billion. That's outrageous. That's outrageous. We think of this as, this is the new normal. Everywhere we go, there's people all around. We think of this as the new normal. That shouldn't be normal. There's too many of us. You look at me like she's out of her mind.
Not at all, no.
Oh. So I'm very concerned about the way we interact. I don't know, I feel like I want to go back and be a Native American Indian. I feel like maybe they had a much better attitude and respect for the natural environment. We're missing that. We're really missing that. So I mean, I don't know. I've just recently tried anyway. I'm not completely there. I've eliminated meat from my diet. Don't eat beef. Don't eat beef. Okay? I'm told the single most effective thing you could do to protect the environment is reduce beef from your diet, because raising of cattle is very destructive. You know, just do something though, do something.
Professor Dawkins?
Okay, is this like the cattle ranching province in Canada? Oops. Well, look, I said it. I just, that's the way.
Professor Dawkins Carolyn, it's a pleasure and honor to talk to you both. My question is for Professor Dawkins. Time and times we see that in your debates, people want to imply that Einstein, for example, believed in God. And of course, you try to educate them how they misunderstood the quotes. So my question is, in a bigger picture, how is it relevant to the truth if Einstein believed in God or not? Since we can see scientists surprisingly on both ends of the spectrum. Thank you.
Yes, well, Einstein, of course, did not believe in God, although he used the word God a great deal as a metaphor for that which we don't understand. He said things like, what I really want to know is, did God have a choice in designing the universe? He meant, is there more than one way for a universe to be, or is there only one way? And similarly, when he said he didn't believe that he plays dice. And he became very irritated by people misunderstanding him as believing in God, and he said so explicitly. And I think one letter that he wrote in German has just come up for auction again quite recently. It's going to be raising some huge price in which he explicitly denies he believes in God. You say there are scientists on both sides. There are a few religious scientists in the sense of people who really, really do believe in Jesus or resurrection, virgin birth and things. They're very few. Most scientists who say that they're religious, if you actually ask them what they believe, they're kind of spiritual. I mean, they have a feeling of what they call awe and wonder, which is a bit of a cliche, but it means what it says, and Carolyn and I both have it in a big way. The Carl Sagan kind of religiosity, which has nothing to do with supernatural, but which is a feeling of reverence, awe, wonder, a sort of burgeoning feeling in the chest when you look up at the stars or look down a microscope. And there are people who will use the word religious for that. And so when you hear that there are religious scientists, ask them what they really believe, and you'll find that it's pretty much likely to be that. Just a few, fingers of one hand almost, among really distinguished scientists believe in the resurrection of Jesus or the virgin birth or something of that sort, but they are very rare.
Does it matter what Einstein's personal belief was?
Well, it shouldn't really matter because what matters is the evidence for what's true. But it's rather hard not to be influenced. Nevertheless, we're human. It's rather hard not to be influenced by the opinions of people that we respect. And so, although it wouldn't in any possible way demonstrate the existence of something just because Einstein believed in it. If he did, it'd give you pause. You want to ask him why. You say, well, tell me, Dr. Einstein, why do you believe in God? And you'd listen to what he said, at least.
Thank you.
But he didn't, anyway.
This is the last question, madam.
Oh, sorry.
Make it good. It's a lot of pressure. I'm one of the founding members of the Atheist Society. Thank you. Short people. Atheist Society of Calgary, and our central, one of our central missions is to build community. And I'm just wondering what some of your thoughts are on some ways that we might do that, some ways that we might build our community here.
Yes, there are movements afoot to have sort of atheist churches where you meet on Sunday and I mean, I respect that. It's probably quite a nice thing to do. You meet friends and maybe have lectures and book clubs and things. It's not my way, but I do respect it, and I think it's very good for people to meet up with other people like mine and just learn that there are other people like yourself. I guess in an enlightened country like Canada, it doesn't much matter. But if you go to Texas, say, or somewhere. I mean, one of the things I find when I lecture in the deep south of the United States is that I do get quite large audiences, and I get the feeling that what they get out of it is each other. I mean, they come and they are surrounded by people. They realize they're not alone. They are part of a community that they didn't realize existed, and so my guess is that the sort of thing you're doing is very valuable from that point of view. I congratulate you for doing it.
Thank you.
Want to have a last word, Karen?
Okay, so I get, We doing one more?
Okay, hello.
No?
Let's do one more.
Okay.
Okay.
Just one more.
My name is John. I'm from Turkey. And in Turkey, evolution is removed from the biology textbooks in high school. And it's really sad.
Not just Turkey.
Not just, like, actually, the Turkey is really important, like, for me, because the founder of the Turkey made mandatory science for the children, and I owe this to my friends, like, talk about this situation. So, like, what are your options? Yeah. Okay. What are your opinions about this sad situation in Turkey?
I think it's tragic because, as you said, Turkey was founded by an enlightened leader, Ataturk, who believed in science. One of the things that's going on in Turkey at the moment is that there's a sort of James Bond villain character called Adnan Oktar, who has published great big coffee table books on creationism. They're fraudulent books. The technique is you have a beautiful color picture of an animal on one side of the page, and on the other side of the page another animal. One of them is a fossil, one of them is a modern animal, and the message every page is, here's a fossil and here's a modern animal, and they're exactly the same, so evolution hasn't happened. Which is obviously a silly argument, but what's even sillier is when you look at the detail, because sometimes, in many cases, the fossil and the modern animal are nothing to do with each other. I mean, there's a fossil eel, I think it is, which is said to be identical to the opposite side, which is actually a snake. And there's one which is a fossil insect, an insect in amber, and the modern insect, which it's supposed to be identical to, is a fishing fly.
Oh, my God.
Made of feathers, and it's got a steel hook sticking out of its back end. And this is a leading creationist intellectual in Turkey. Yes, it's a tragic situation, and your countrymen need to fight it.
Okay.
All right, everyone, please give a huge round of applause for Carolyn Porco and Richard Dawkins. All right, thank you guys so much for coming. Those of you who have a book, a Richard Dawkins book, there will be a book signing in the lobby. Please get home safe. Again, thank you so much for coming, and let art and science inspire. Thank you.